In this video, we'll be doing a couple stoichiometry questions where we use the proportions from the reaction and solve for a different proportion. That problem solving method in chemistry is called stoichiometry. So let's go ahead and start. So this question says, how many moles of magnesium are required to react with 2.6 moles of hydrochloric acid? So we'll need a balanced reaction to answer this question. And then we'll start by setting up a GCD table. So let me go back to that slide. So we'll start our GCD table. So I'll write G, C, and D. And we want to identify our given first, our desired, and then find out where we are on here on the flowchart, and then we can figure out what conversion factors we need. So that would be the third thing we'll do. And then the fourth thing is once we figure out where we're starting and where we're going on here, once we figure that out, then we could go ahead and solve. So it says how many moles of magnesium. So it says how many moles of magnesium, that's our desired, are required to react with 2.6 moles of hydrochloric acid. One thing should jump out to you and when you read these kinds of problems is that you have moles of one thing and you're trying to convert to moles of something else, and those two things are related by their chemical reaction. So this problem, in these stoichiometry problems, they're going to mention two things. So let me go back to that. So they're going to mention two things, magnesium and hydrochloric acid. And as you see in the balanced reaction, there's four things, 1, 2, 3, and 4. Now, two of these things are related in this question. So these stoichiometry problems can relate any two things in the reaction. This one just happens to be relating HCl, hydrochloric acid, and magnesium, these two. However, these kinds of problems, they can relate any two mole ratios that are of interest. So this problem could just as easily be relating this one and this one, or hydrogen gas and this one, and so on. Okay, so let's go ahead and write our given. So our given can be identified by the number and unit and substance. So this is our given, 2.6 moles of HCl. So we're going to write it here, 2.6 moles. I'll write 2.6 mole HCl. And our desired is how many moles of magnesium are needed to completely react all 2.6 moles of hydrochloric acid. So I'm going to write question mark mole Mg, since I'm looking for moles of magnesium. Okay, it doesn't say magnesium chloride, or it doesn't say hydrogen gas, it just says magnesium. So it's referring to this one. So this problem is relating HCl. So it's hydrochloric acid, so it's going to be this substance, and it's going to be this substance, Mg. So it says moles of magnesium. So it's talking about this one. So somewhere in the problem, I'm going to be looking at this ratio, this 2-to-1 ratio that they react in. Okay, so that kind of leads me to the next thing, and that's to look and see where we're at on this flow chart here. So it says moles of HCl. That means we're not starting here at the scale. We're not starting here. A lot of times you would be in these kinds of problems, but on this problem we're not. We're actually starting right here. Let me use the yellow highlighter to try to keep it consistent. So we're starting here at moles of HCl, 2.6 moles of HCl, and we're trying to get to moles of magnesium. So we're trying to get to this other mole here. Okay, so that's it. This problem is only going to take one step. We just have to go from here to here. And so to cross this bridge, to go from moles of one thing to moles of something else, then this is our conversion factor. This is it right here. Okay, and if you read this, it says we're going to write this right here. We're going to write that right here in our conversion table, the column for conversions. So right here, it's you get these. I left them blank right here because they're different for every reaction. So I made this flowchart super generic to fit any reaction. So I'm gonna write this. It says from coefficients from the balanced mole ratio from the balanced reaction. So those numbers are blank because you get them from here, the 2 and then the 1. Okay, so you actually call these coefficients are actually called moles. So I'm going to write 2 moles. So I get it from here. So I'm going to write 2 moles of HCl equal 1 mole of Mg. Okay, and now I'm ready to solve this. So I write 2.6. So I just rewrite my given 2.6 moles of HCl times. I make a line, and I have mole of HCl, so I want it to cancel with this right here. So I'm having a little bit of trouble with this slide, keeps moving on its own. So I'm going to write 2 moles of HCl on the bottom, and the other part of the conversion factor, 1 mole of Mg, goes here. Okay, so mole of HCl and mole of HCl cancel, and so the answer is 2.6 divided by 2, or 1.3 moles of magnesium. Okay, and if we read what we just did, is we figured out that since they react for every 2 moles of HCl, you require only 1 mole, half as much Mg. So that's why you see that it's 2.6 divided by 2. Okay, so these are the proportions given by. So these are the proportions given by the reaction, and then you see that you need half of that in the reaction. Okay, this next one I'm going to do is a mass-to-mass problem. So we'll see that this appears a little bit different, but a lot of things are the same. So here's the problem. It says what mass, so it says what mass of H2 will be produced when 3 grams of aluminum reacts, and it says with excess hydrochloric acid. It's just saying you have plenty of this. You don't have to worry about it running out. So we'll start by writing our given. It says 3 grams of aluminum. So I'm going to write 3 grams of aluminum here. So I'll write 3 grams. I'll just write 3GAL, 3 grams of aluminum. And the desired is what mass of H2. So I'm going to write question mark. I'm going to write question mark grams H2. So now the next thing to do, that's the first thing, next thing is to find our conversion factors that we need. So this time you see that it's 2 different things. It's aluminum and H2. So it's relating aluminum and H2. These are the 2 that it's relating. You don't really have to worry about the other 2 things because this problem doesn't involve those. So it's just not asking about those 2 things. So we're actually starting at, I wrote X and Y on. So I wrote, on your flowchart, I wrote X and Y to represent the 2 different substances. So on this problem, we're starting with grams of aluminum. That means we're starting here. And we're trying to figure out grams of something else. That means we need to go all the way across to get grams of H2. So we have grams of one thing, and then we're asked to find grams of something else. Okay, so that means we're starting here, and we're ending here. So this problem should take you, you have to get the grams of aluminum to moles of aluminum, then moles of H2, and then to grams of H2. So this is going to take 3 conversion factors. We'll need the molar mass of aluminum. So I'll write 1 mole of aluminum is 26.98 grams. And then we need the coefficients that they react in. So I'm going to write 2 moles of Al, and I'll set that equal to 3 moles of H2. So, and I get the 3, so I get the 3 and the 2. So I get the the 2 and the 3 come from the balance reaction, the 2 and 3, and then I just call them moles because they're quantities. So so that puts us here. If I end the problem now, I will have moles of H2, but this problem's asking for grams of H2, so I have to do one more step, and it's a molar mass step of H2. So I write 1 mole of H2. It's 2 atoms of H, so that's going to be 2.02 grams of H2. And now you're ready to solve. So that's the last thing to do. So I just rewrite my given, 3 grams of aluminum. I'll put it over 1 times. And here's my grams. Here's my grams of aluminum. So I want to match that up by putting it here. So I'm going to write grams, 26.98 grams Al. And the other half of that term goes on top, 1 mole of Al. So that cancels. Okay, and I've used that conversion factor. Now I want to switch to, here's the part where you go mole to mole and use the ratio they react in. So I'm going to write, I have moles of aluminum here. So here's moles of aluminum, the unit. So I'm going to put that right here. So I'm going to write 2 moles of Al and 3 moles of H2 on top. So those two cancel. Okay, and I've used that conversion factor. And now I have moles of H2 here, and my mole of H2 is right there. So I'm going to put that 1 mole of H2 right here, right here. Okay, so I'm going to write 1 mole H2 right here, and then 2.02 grams of H2 on top. Okay, and then those cancel. Okay, and so now I get, I'll have to plug this into my calculator. Okay, so I'll go, I kind of like this fraction deal here where you can enter in everything. So 3 times 3 times 2.02. I'll go down to the bottom, 26.98 times 2. Okay, I got everything. I think I got everything entered. Okay, so 0.34, I'll just round it after the second decimal, so 0.34 grams of H2. So to answer, what did I just figure out, is if I have 3 grams of aluminum, so if I start with 3 grams of aluminum and I pour hydrochloric acid on it, on like aluminum foil, it's going to generate 0.34 grams of hydrogen gas if I do that, carry out that reaction. So the next 2 slides, I have examples for you to try. Okay, so let's go to the next slide. So this one is a mole-to-mole question. So here's the balanced reaction. So see what you could do on this one. And by the way, GCD is required. So a GCD table is required. And by the end of this unit, we'll practice doing these without GCD tables. So we're getting real close to that actually. So we'll see what you get on this question. And I have one more question. So this one is really test yourself on this one. I want to see, how far you can go with this. This one question has basically everything from this unit in this one question. So it's a good review if you could answer this. So it says how much oxygen gas is required to completely react with 50 grams of propane. And it tells you the products of the reaction are carbon dioxide and water. Okay, so let me give you a couple hints. So it has every topic from this unit. So you'll need a balanced reaction. That means you'll have to be able to name everything. So oxygen gas, you'll have to know that that's a reactant. Propane is the other reactant, so you'll have to come up with the formulas for those. And it says the products, so these are the things on the right of the arrow, carbon dioxide and water. So you have to write the names of everything and then balance it once you have all the subscripts right. And then we'll set up a GCD table, identify the given and desired, see where you are on the flow chart. So use your mass-to-mass flowchart, see where you are, and then go ahead and try to solve it, and we'll see what you guys can come up with that. So that's the end of our video.